Mathematics Paper 1, Karnataka University, Dharwad. And in this session, I would like to discuss Cauchy sequence and examples and its properties. And now we shall see the definition of Cauchy sequence. Now let me see that definition here. A sequence n is said to be Cauchy sequence if given epsilon greater than 0, however it may be small, there exists a positive integer m such that magnitude of an minus am, it means modulus of an minus am, should be less than epsilon. For all n should be runs from, that is after n and equal to n. So that means that's distance between that or length between an and am, which is very close to each other, that is. Or else we can define in another way that a sequence an is said to be Cauchy sequence if given epsilon greater than 0, however small, there exists a positive integer m, small m, such that so modulus of an plus b minus am should be less than epsilon for all p is positive, this is greater than 0, and this p is member of that natural numbers. So it means what? It is same one and the same in the above as we have defined that. So or else another way also we can define that this Cauchy sequence. A sequence an is said to be a Cauchy sequence if given epsilon greater than 0, however small, there exists a positive integer m such that modulus of ap minus aq should be less than epsilon. For all these p and q are the members of this small integer m. So that is what these are the three definitions are one and the same there. So that is what it is, the Cauchy sequence concept. Now we shall see that properties of Cauchy sequence. In the first property, every Cauchy sequence is bounded. So it means now we shall see in the proof of this every Cauchy sequence is bounded. So let us take a sequence P, a Cauchy sequence, that an. So we choose that is epsilon is 1. Then by make use of the definition, by definition there exists a positive integer m such that modulus of an minus am should be less than 1. For all n should be greater than or equal to m. That means an is lies between am minus 1 and am plus 1. As for all m, n, it is greater than or equal to this m, small m. Now let us take small k, which is the minimum among the terms, that is a1 to am minus 1 and am plus 1, that which includes inferior left as well as right term of that an also there. And also we can capital KB maximum among these, that all the terms there. Now then this an is lies between small k and capital K. It means it has its bounds. So that therefore this sequence is a bounded sequence. Thus we conclude that every Cauchy sequence is bounded. But converse of the above theorem is need not be true. That means that every bounded sequence need not be convergent. For example, we'll have that sequence an is minus 1 power n. It is a oscillatory sequence. Definitely this oscillatory sequence, but it is a bounded sequence, but it is not a Cauchy sequence. Means it is bounded between, that is bounds between minus 1 and plus 1, but it is not a Cauchy sequence because since it does not holds good for the definition of Cauchy's concept. So that's why it is not a Cauchy sequence. Now let us see the problems on this here. So show that sequence 1 by n is a Cauchy sequence. Let us take sequence epsilon greater than 0 be given here, and we can choose for p is greater than 1 by epsilon, that inverse of this epsilon. And also we have that for all m, small m and capital small n should be greater than or equal to this p. It means what? This m and n are greater than or equal to 1 by epsilon. That means here 1 by m and 1 by n, it should be less than or equal to 1 by p. Inverse of these here m and n, it should be less than epsilon. So that means 1 by p, it should be less than epsilon. Therefore 1 by n minus 1 by m, 1 by n less than epsilon. It means magnitude of this here less than epsilon. Therefore 1 by n is a Cauchy sequence. So next, in the next problem, we prove that an is n by n plus 1 is Cauchy sequence. Now again, let me epsilon greater than 0 be given, and let n should be greater than small m. Now take the magnitude of an, modulus of an minus am. An is n by n plus 1, am is m by m plus 1, so that you can take n is common, m is common, so that this plus 1 and minus 1 gets cancelled. It's that 1 by m plus 1 and minus 1 by n plus 1. So as we know that n is greater than m, n plus 1 is also greater than m plus 1. So but inversely that n by n plus 1 is less than m plus 1. So therefore modulus of an minus am should be less than 1 by m plus 1. Again it should be, definitely it is less than 1 by n, and again it should be less than epsilon whenever m is greater than 1 by epsilon. So therefore that we conclude that modulus of n minus am should be less than epsilon for every epsilon greater than 0. Hence this problem, this sequence n by n plus 1 is also Cauchy sequence. We have discussed in this lecture, first we have discussed the Cauchy sequence definition, and also we have seen that is the Cauchy's properties of Cauchy sequence, and lastly we have discussed the few examples on Cauchy sequence. That we have referred these books in this lecture for making these notes. So thank you.